All right, welcome to week 2. We are going to continue our discussion with apportionment and voting, moving to section 4.2 and talking specifically about voting. So, at first glance, you might think counting votes is pretty simple, pretty straightforward. You take the votes, you count them, the biggest number wins. And that can be true, especially if you only have 2 candidates and you just care about who got the majority. However, if you add more candidates, things can get very complicated very quickly. So we're going to look at what the different methods of counting votes are, what different methods are used, and then we're also going to talk about how to evaluate whether those methods are fair and how to determine which method is the most fair. The simplest I just mentioned is the majority vote. So majority vote just means that the winner has to have more than 50%. So again, if you have multiple candidates, that can be difficult because if you have, say, even 4 candidates, right, everyone could only get 25% of the vote or, some variation within there, but not close to 50%. So you would either have to have multiple elections or a secondary way to determine the winner. Any number above 2, it becomes possible that no one will get the majority of the vote. So plurality is the next form of voting that kind of makes sense after that, and it's just whoever gets the most votes wins. What can be problematic with that is if you're voting for, like, say, the leader of a country, the winner could conceivably have, 25 or 30% of the votes, depending on the number of candidates you have. So the person who is chosen to lead the country could actually only be favored by a small portion of the population. So that has problems for obvious reasons. So that led to other methods that are more complicated, and those are explained in your textbook, but one is called the Borda counting method. So the Borda counting method actually will allow the voters to rank the choices. So instead of just pick your favorite, it'll be rank the 4 if there are 4 candidates, right? Rank them 1 through 4. Then when you count those, you assign each ranking, like number 1 gets a certain number of points. It would get the most points, right? Because it's the most favorable. So say you have 4 candidates, number 1, you might assign 4 points. A second place choice would get 3 points, 2 points, and so on down. And then you total up the total number of points that each candidate gets to see who wins. You also can have runoffs. So maybe you do your Borda counting method once and you eliminate the bottom winner and then you have a runoff election. So that's an option there. Another method that you're going to look at is plurality. And plurality is, again, with elimination. So plurality is what we already talked about, right? Like, it was the method where if you get the most votes, you win. But in that case, like I said, where maybe your top winner only has 30% of the votes, instead of just putting them in office, you want to have a runoff election. So you would have a plurality vote. You would eliminate the lowest vote getter, and then you would have another vote. And you could do that as many times as you wanted, which seems like a pretty great way to choose the winner, but that can be very costly and time consuming. If you have 6 candidates and you have to do runoffs over and over again, that's not always feasible. So again, we need to balance fair with efficiency and cost effectiveness. So all of those things go into determining how you count votes. There's also a method called pairwise comparison, and this involves creating a chart and comparing each candidate head to head. So did candidate A beat candidate B if we just looked at those 2? Did candidate A beat candidate C? And you assign points, sort of like in the Borda method, total them up and see who comes out on top. So interestingly, in 1948, Kenneth Arrow was a guy, a mathematician, working on his dissertation, and he decided to evaluate or try to create a fairness criteria for voting. So voting, obviously, when you're when the person that you want to win doesn't win, right, it becomes a very debated, a very passionate issue about, was this fair? Was it done right? So he said, okay, let's create a fairness criteria. Let's figure out what are the things that need to be true for the vote counting method to be fair, that we can say it's fair, it's good, this will work. So he did. He came up with 4 criteria. You will look at those in your textbook. You can read those. But one, for example, one was if a candidate receives a majority, in other words, they got more than 50%, they should win. No matter which voting method you use, if they receive the majority, they should win. That seems logical. Probably no one would disagree with that. But you will find when you're reading through your textbook that some of these methods, that's not always true. I think it's the pairwise comparison. If there is a way in that vote counting that the person with the majority of the votes might not win. So that would mean that that violates a fairness criteria. So he established 4 rules that all vote counting should follow. Interestingly, as he continued his work, he was actually able to prove definitively that it is impossible to meet all the fairness criteria. So in other words, if there are 3 or more choices, like I said, if you have 2 choices, counting votes is pretty straightforward and simple. But if you have 3 or more candidates, he proved mathematically that it is impossible to count votes in a way that will meet all 4 of the fairness criteria that he established. And that's still true today. At this point in time, no one has created a system to count votes when you have 3 or more candidates that would be considered fair under Kenneth Arrow's fairness criteria list. So I hope you find that very interesting and maybe sheds a little light on why our presidential elections are always so hotly debated, because vote counting is not straightforward. There's not a systematic way to always ensure that the fairness criteria are met. So you're going to work through counting votes using those different methods in your book, and you're going to evaluate them for fairness criteria. You'll see some of those paradoxes that arise. So let me know if you have questions, and I'll be happy to answer them.